In this unit, we're going to be talking about the nature of exponential growth. So it has the following properties. The independent variable increases by a constant amount and the dependent variable increases by a common factor. The graph also increases at an increasing rate, hence exponential growth. The finite differences exhibit a repeating pattern, so the ratio of successive to finite differences is constant. Here is an example of this idea. So we have our x and our y values, and if we find the first, second, and third differences of our y values, we get to the fact that the last number will be 2. How to find the first differences or any differences is you subtract the bottom term from the top term. So 4 minus 2 is 2, 8 minus 4 is 4, 16 minus 8 is 8, and so on and so forth. And you can see as we go on to the next difference, so from first difference to second difference, one of the bottom numbers disappear. So this 64 disappears, the 32 disappears, 16 disappears, 8 disappears, and then 4 disappears, leaving the final number to be 2. You might ask yourself, why does that happen? The reason is the ratio of successive finite differences is constant. So if we divided the ratio of 4 over 2, it would be 2. 8 divided by 4 is 2. 16 divided by 8 is 2, and so on and so forth. And so hence this is exponential growth. So I want you guys to note that any non-zero number with an exponent of 0 is equal to 1. So for example, b to the power of 0 is equal to 1 if b is in R, so b is any real number, and of course b cannot be equal to 0. So here is a multiple choice question. So a bacteria colony affects a classroom with an initial population of 20, infecting quadruple people every hour. So which equation models this exponential growth? A is incorrect because the first term of your equation must be the initial population. So we can already rule out and X out A because it starts with 1. Whereas your initial term must be 20. The correct answer from these 4 is that the second, the one in which it multiplies by, is quadruple because it infects in quadruple people, so this is the amount it's increasing by, and hence you would put it as a second term. So it would be 20 times 4 to the power of x, and x being every hour, so the number of hours. So the next problem is that Nadia owns a chain of fast food restaurants that operated 200 stores in 1999. If the rate of increase is 8% annually, so every year, how many stores does the restaurant operate in 2007? So y after 1999 is the x value, so years after 1999, and the number of stores that have opened. So we have 0, 1, 2, all the way to n, and 0 represents 1999, 1 represents 2000, 2 represents 2001, and you get the gist. For our store side, we know that in 1991, Nadia operates 200 stores, and then in the next year, she operates 8% more. So for this, you would do 10 divided by 8, which would give you 0.8, and because it is an exponential growth and it's increasing per year, you're going to do plus 1. So it's going to be 1 plus 0.8 times, and then the number of stores previous to it, so it would be 200. When you solve this, you would do 1.08 times, this little dot is times 200, you would get 216. For the next year, so 2001, you're going to do 1.08 times the previous number, which was 216, and you're going to get 233.28. Now, if you if you continue this pattern, you're going to get n is going to be 200 times 1.08 to the power of n being the number of years. So n is representative of any general number. This means if you're trying to look for the 50th year, you can just plug in 50 to n and you can solve for how many stores she's going to open. This question is specifically asking how many stores she operated in 2007. So let's see how this is done. For this specific problem, n is going to equal to 8. How we solve for this is we're going to do 2007 minus the initial year, so year 0, which was 1999. When you subtract these two numbers, you get 8. So all you need to do is sub an 8 into the nth term, so as the power of 1.08, and you're going to get 200 times 1.08 to the power of 8, in which you get 370 approximately. Why we rounded to the nearest whole number is because she can't have point a number of stores. You have a whole number of stores, so you're just going to round it to the nearest whole number.
In this section, we will be talking about exponential decay. Exponential decay is the pattern in which each term is multiplied by a constant between 0 and 1. Because it is being multiplied by a constant between 0 and 1, it is decreasing, as can be seen in the graph next to it. The pattern of finite differences is also repeating for exponential decay, as can be seen in the chart where the first term is 10 and the second is 5, and between them both the factor is 1/2, and then from 5 to 2.5 it is also 1/2, and then from 2.5 to 1.25 it is also half. In this section we will be talking about negative exponents. To make positive exponents negative, you take the exponent will be a to the power of b, and you have to put this into the fraction, so it will be 1 over a to the power of negative b. An example for this could be 2 to the power of 5. To express this as a negative, you do 1 over 2 to the power of negative 5. So and the same thing can be done to express negative exponents as a positive. So if the negative exponent is a to the power of negative b, you put it into a fraction, so it becomes 1 over a to the power of b. So the example for this would be 2 to the power of negative 5. To express it as a positive exponent, you do 1 over 2 to the power of 5. This can be done if your question asks to express the answer in positive exponents or negative exponents. This can be used. In this section, we'll be doing a word problem for exponential decay. So the word problem is the radioactive isotope uranium has a half-life of 2 hours. How long will it take for 60 milligram sample to decay to 20% of the original amount? So just to note, the half-life is the time it takes for a substance to decrease to half of its original amount. To solve this word problem, we must first make an equation. Since we are calculating 20% of the original amount, the A value will be equal to the quantity of the original amount, so 60. This can also be seen if you set your exponent value to x, to 0 and solve for A. So since the exponent is 0, B is going to be 1, and so A is going to be 60. So your equation then is going to be y equals 60, b to the power of x. To solve for b, you can put the amount that you have after one half-life, which would be 30, as y, and make the exponent x equal to 1, since this is after your first half-life, and solve for b. So it's going to be 30 divided by 60 is going to be equal to 1/2. So your b value is 1/2. So your equation is y equals 60 times 1/2 to the power of x. Solve the question of how long it will take for 60 milligram sample to decay 20% of the original amount. We are going to set our y value to 0.2, so 20%, to times 60. This is because we are looking for 20% of 60. So it's going to equal the rest of the equation, which is 60 times 0.5 to the power of x. Because you have 60 on both sides, they are going to cancel each other out. So your equation is going to be 0.5 to the power of x is equal to 0.2. Now you have to take the log on both sides. So for 0.5 to the power of x, it's going to be x log 0.5. And then for 0.2, it's going to be log 0.2. To isolate for x, you're going to divide both sides by log 0.5, which is going to make your x value equal to 2.32. Since that is the number of half-lives, and each half-life is 2 hours, we will be multiplying the x value by 2. So it's going to be 2 times 2.32, which equals 4.64. So that is how long it will take for the 60 milligram sample to decay 20% of its original amount, 4.64 hours.
So, 3.3 rational exponents. To begin, a power with a rational exponent that is 1 and with a denominator n can be written as the nth root of the base. So b to the power of 1 over n can be written as n square root b. A power with a rational exponent with numerator m and denominator n can be written as the nth root of the base raised to exponent m. So b to the power of m over n can be said as n square root b to the power of m, the entire thing to the power of m. These rules hold for any powers involving rational exponents. So for example, if we had 32 to the power of 1 over 5, we can write 32 as 2 to the power of 5, and now the equation will become 2 to the power of 5, the entire thing to the power of 1 over 5, to the power of 1 over 5, because we only converted 32 to 2 over 5, we never really touched the 1 over 5 yet. So that's why the exponent 1 over 5 remains the same. And now what we can do is we can evaluate, since there's two exponents, they get multiplied. So 5 times 1 over 5 is 1. So the final answer becomes 2 to the power of 1, or you can just say equals, well, 2. Converting something from a positive exponent to a negative exponent is really easy. Just reciprocate it and change the sign on the equation. For example, 4 to the power of 2 will become 1 to the power of 4 to the power of negative 2. This is because 4 is, well, 4 over 1. And when you reciprocate it, you flip it. So it'll be 1 over 4, and the sign of the exponent changes when you flip, so negative 2. 6 to the power of negative 8 will be 1 over 6 to the power of 8, because once again, 6 is 6 over 1. Flip is 1 over 6. Change the sign. According to the rule, that's what you do. Then it'll be 1 over 6 to the power of 8. Moving on to the word problem. The following formula relates the volume V and surface area S of a sphere. So this is the equation. Find the volume of a spherical holding tank with a surface area of 200. So we know that S has to equal 200, and S is located right over here. So let's do that right now. So V of S equals 4 pi negative 1 to the power of negative 1 over 2 divided by 3 times S 5 over 2. Now S, as we determined, was going to be 200. So let's write 200 over here. 200 to the power of 5 over 2. Now, first thing we have to do is evaluate this. Now, 4 pi to the power of negative 1 over 2 will give you 0.282. Next thing we have to do is determine 200 to the power of 5 over 2. Now remember, 200 to the power of 5 over 2 can be written as square root of 200 times 5. Now, this will equal 14.142 is what square root 200 equals. To the power of 5 will give you 565,685.425. Now, this entire thing becomes this, and this becomes this. So now your final clean equation will be 0.282. V of S equals 0.282 divided by 3 times 565,685.25. So 125. Now if you evaluate this, this is 0.094 times this number will equal 53,174.43 meters cubed. Because it is volume, it must be meters cubed. So this is our final answer for this question. And that was 3.3 rational exponents. 3.4 properties of exponential functions. So to start, looking at the standard equation y equals ab to the power of x, we can determine that if the a value is greater than 0 and the b value is greater than 1, then the function is increasing like so. So if the a value is 1 and let's say the b value is 2, it will be increasing. The function is decreasing if the a value is greater than 0 and the b value is between 0 and 1. So if the a value is, let's say, 0.5 and the b value is 0.3, then it will be decreasing. The function is also decreasing if the a value is less than 0 but the b value is greater than 1. So in this case, let's say the a value is negative 2 and the b value is 3. Then the function will also be decreasing. The function is increasing if the a value is less than 0 and the b value is between 0 and 1. So let's just say the a value is -1 and the b value is zero point 0.4. This function will be increasing. The function ab to the power of x, where a is greater than 0 and b is greater than 0, will have the domain of x in R, range of y in R, y has to be greater than 0, horizontal asymptote at y equals 0, and a y-intercept of the a value. So example, y equals 4 and 6 to the power of x. The domain will be x in R, the range will be y in R, y has to be greater than 0. The horizontal asymptote will be at y equals 0. The y-intercept will be y equals 4. So coordinate formula is 0, 4. This is because we previously determined the y-intercept is the a value, and the a value is 4. The function ab to the power of x, where a is less than 0 and b is greater than 0, will have a domain of x in R, range of y in R, y has to be less than 0, horizontal asymptote at y equals 0, and a y-intercept of the a value. Example, if we look at y equals -2, 0.5 to the power of x, the domain will be x in R, the range will be y in R, y has to be less than 0, the horizontal asymptote will be at y equals 0, and the y-intercept will be at y equals -2, or this coordinate form, also because the a value is -2. So if you look at the equation y equals 6, 1 over 2 to the power of x, since both a and b are greater than 0, we can conclude that the domain is x in R, range is y in R, y has to be greater than 0, the horizontal asymptote is y equals 0, and the y-intercept is 6, because a value is 6. So when graphed, it'll look something like this. And here's the a value at 6. And you can see that although this line gets close to 0, it will never really touch it. And the reason that we can conclude this is because a and b are greater than 0. And if we look up, our rule says that when a and b are greater than 0, these will be the properties, which are the exact same as over here. Moving on, create an equation for the following graph. So first things first, let's look for a. We can see that the y-intercept is 8. So 5, 6, 7, 8. So right over here. So we can conclude that the a value is 8. I'll see if the horizontal asymptote is y equals 0. And since all the y values are greater than 0, because look, there's not a single y value under 0, we can conclude that the range is y in R and y has to be greater than 0. For domain, this can be any x value. Remember, this is actually something like this. So this goes on forever. This will go on forever and ever and ever. This will go on forever and ever and ever. Therefore, there's an infinite x value. So we can just say it's x in R without restriction. To get the b value, we must substitute a set of coordinates other than the y-intercept. So we'll sub in -1, 4, because you can see -1 and 4 is right over here. And it intersects the function. So note the a value is 8, so we can say that 4 equals 8, which is the a value, b, and x was -1. Now, next we can do is divide 4 by 8 to get rid of this, so it'll be 0.5 equals b, -1. Now, we can also say we can also write 0.5, if you remember 3.3 as being 1 over 0.5, the whole thing exponent -1 equals b to the power of -1. Now, since these are the same, the powers, the exponents, what we can conclude is that 1 over 0.5 must equal b. Now 1 divided by 0.5 is 2. So 2 must equal b, which is correct because when I made this graph, that's the exact same formula that I put in. It was 8, 2x. So moving on to the word problem. A radioactive sample has a half-life of 4 days. The initial sample is 600 milligrams. So the keywords. So we have to write a function to relate the amount remaining in milligrams to the time in days. Since the initial sample is 600, the y-axis starts at 600, so which means that y-intercept is 600, which we know from before that when the y-intercept is 600, the a value is 600. Therefore, the a value is 600. Now it's a half-life, so it diminishes by half its value at this rate. So therefore, the b value must be 1 over 2 because it's half to the power of x over 4. It's over 4 because the half-life is every 4 days. So if we divide the amount of days by 4. So now we must restrict the domain of the function so that the mathematical model fits the situation it is describing. So since time cannot be negative, the domain can be written as x in R. X has to be greater than or equal to 0. So this is because if we look at the graph, all of this is negative. Now if this is time, 1, 2, 3 days, 4 days, 5 days, you can have a negative day. So we end the graph here by writing this. And that was 3.4, Properties of Exponential Functions.
Today I'm going to be talking about 3.5, which is the transformation of functions. So the transformation of an exponential function is done the same way as any other function, for example, a parabola. And the transformed equation for an exponential function looks like this. Y is equal to ab to the power of b bracket x minus h bracket plus k. So the uppercase b in this equation represents the base function, which is y is equal to b to the power of x. And so I'm just going to go through the basic transformations, which are a, b, h, and k. So if a is negative, it means it's reflect upon the x-axis. If a is between 0 and 1, it's compressed. And if a is greater than 1, that means it's stretched, all by a factor of a. And if b is negative, it represents that it's reflected in the y-axis. If it's between 0 and 1, it means it's stretched. And if it's greater than 1, that means it's compressed horizontally both by a factor of 1 over b. So horizontal and vertical translations are very similar. So if h is greater than 0, that means it translates h units to the right. And if it's less than 0, h units to the left. And if k is greater than 0, it means it moves k units up, and if less than 0, k units down. So if we were given a question to describe what's happening to go from the base equation to the transformed equation, an example would be right here. So the base equation is y is equal to 2x, and the transformed equation is y is equal to 2x plus 4. So we know the base is 2x. So all the transformations that are happening are just the 3 and the 4. So the 3 is the a value and the 4 is the k value. So we can say it's being vertically stretched by a factor of 3 and it's moving 4 units upwards. And now if we were to graph this, we would need to graph first. We would need to have a table of values for the base function and a table of values for the transform function. But in order to do the second one, we would need this, which is known as the mapping notation. So we would take this and plug it in here. So we know that b is 1, and so 1 over 1 is 1, and we have no h, so it's 0. So our x values for both are going to stay the same. They're going to stay the same. And for our y values, we are multiplying the y by 3 and adding 4, because adding k. And so these are our new y values. So now we're just going to go ahead and graph this. So we know our horizontal asymptote is going to be 4. So we're going to draw a line, and we're going to plot the points. So negative 1 is going to be 5.5. 0 is going to be 7, and 1 is going to be 10. So our graph should look something like this. And if we were to look at the graph, we would have to talk about the horizontal asymptote, the domain, and range. So the horizontal asymptote is going to be 4, so we would write it as y is equal to 4. The domain is going to be x and r because it's increasing from left and right. And for range, we would write y in r, but y has to be greater than 4 because it never touches 4.
So today we're going to be talking about making connections and applying exponential models to real-life situations. So here's our word problem. It states Best Buy had a constant growth since 1995. Its profits are modeled using this equation right over here. So the first question asks to create a table of values to show the annual profits, so the yearly profits for year 0, which is 1995, it's the current year for this problem, and each of the following 10 years. So now I've went ahead and created my chart. So for the x values, we have the number of years going from 0 to 10. And for the profit in terms of the year, I went ahead and plugged in the t values into our equation, which I've written right on the side over here. And I've solved for p to the t correlation. So for example, let's take this right over here. On the third year, we're going to substitute t to be 3, and then you just do 1.59 to the power of 3 times 7.4, which is going to be 29.8. So you're going to do this for all of the terms until you get to your 10th term. So the next question is asking, what is the company's profit in 1995? So when the year is 0. Without looking at your chart, what you're going to do is input it into the equation. So when you replace t with 0, you're going to get 1.59 to the power of 0. Any number to the power of 0, as we learned in 3.1, is 1. So 7.4 times 1 is going to equal 7.4. Therefore, their profit is going to be 7.4 million in the year 1995. The next question asks, what is your profit in 2015? In order to solve this question, we're going to do 2015 subtracted by the year 0, which is 1995, and we're going to get 20, hence t is equal to 20. All you're going to do is need to sub this number into the value of t and solve for p20, which is going to give you approximately $79 billion. So the profit in 2015 is approximately $79 billion. So the last question asks, when does your profit reach 500 million? So we're going to make our t value to be 500, and that is equal to 7.4, 1.59 to the power of t, and we are solving for t. So what is the value of t? In order to isolate t, we're going to first divide by 7.4, so 7.4 on both sides, because whatever you do to one side, you must do to another. So what this is going to do is it's going to cancel these two out. Next, you're going to get 500 divided by 7.4, which is going to give you 67.6. So again, if you divide these two numbers, you get 67.6 is going to equal to 1.59 to the power of t. Now we're going to introduce something different. We're going to be talking about log. Now, in order to bring down an exponential or an exponent, in order to solve for it, you're going to need to use a log function, which is also on your calculator. So just like dividing, multiplying, whatever you do to one side of the equal sign, you're going to need to do to the other. So what we're going to do first is we're going to say log 67.6 is equal to, let's make a point, t log 1.59. So again, we're going to take down our exponent, which is t, so now we can solve for it. And so now it's going to be regular, how we usually would solve it for t, which is now dividing. So as you can see here, all I did was divide log 1.59 with itself and on the other side. So these two now cancel out, and you're going to get log 67.6 divided by log 1.59 to equal to t. Now all you need to do is punch in on your calculator these two numbers and divide them together, and you're going to get t to be equal to 9.0 So in approximately 9 years, you're gonna reach $500 million. Now, in 9 years, how much is 9 years? So all we're gonna do is take our year zero, which is 1995, and add it to approximately 9 years, and you're gonna get 2004. So the profit reaches 500 million in 2004, or 9 years.
Now we will be doing another word problem. Janine bought a car for $20,420. The value of the car will depreciate by 10% of the current amount each year after she purchased the car. So we have to write an equation to represent the value of V of the car after T amount of years. So V is going to be the value of the car and the T variable is going to represent the amount of years. So our A value for the equation is going to be the initial value of the car, which is $20,420. Since it depreciates by 10% of the current value, this is going to be our A value. The depreciation rate is going to be 0.9. Since it is decreasing by 10%, we have to subtract 0.1 from 1, which is going to equal 0.9. So our final equation is going to be Vt is equal to 20,420 times 0.9 to the power of t. So the second part of the question is, how much will the car be worth in 6 years? So since the t variable is supposed to represent how the years after the car is purchased, the t will replace the t with 6. So it's going to be 20,420 times 0.9 to the power of 6. So now you have to solve the exponent, so 0.9 to the power of 6 first, and then you have to multiply it by 20,420, which is done here. Your final answer is going to be $10,852. So that is how much the car is going to be worth after 6 years.
So this is the tips portion of chapter 3, and a question is find x and y if you are given an equation like this and an equation like this. So to solve this, you would need to simplify the first equation and the second equation to find x and y. So first, we're going to simplify the first equation. And in order to do this, we have to express each coefficient as a power of 2. So I've wrote down all of the ways you can express it. So you can write 16 as 2 to the 4, x plus 2y over 2 to the 3, x minus y is equal to 2 to the 5. Since 2's are common in both left and right, you can cancel them out and use distributive property on the two equations. So you will end up with 4x plus 8y over 3x minus 3y, which gives you 5. And now you subtract, so you get x plus 11y is equal to 5. So this would be our first simplified expression of this. And now we would do the same thing with this one. And so I've already written down how you can do it because it's the same as the previous. So all we have to do is write 2 to the 5 x plus 3y over 2 to the 4 x plus 2y is equal to 1 over 2 to the 3. Remember, we can express this as negative exponents, so we can write 2 to the negative 3. And since we have 2 less common, we can cancel it out and use distributive property to get 5x plus 15y over 4x plus 8y equals to negative 3. And now we just subtract, so we'll get x plus 7y is equal to negative 3. So we have our two equations, and in order to find x and y, we can use either elimination or substitution. In this case, elimination would be best because x has no coefficient. So if we eliminate x, we have to subtract. So we have to do 11 minus 7 gives us 4y, and 5 subtracted, negative 3, gives us 8. Now we divide both sides by 4, and then we get y is equal to 2. And now we sub in y value in either of the two equations. So we can sub it in into the second equation. So we'll have x plus 7 times 2 is equal to negative 3. X plus 14 is equal to negative 3. X is equal to negative 3 subtracted by 14, which gives us, as x is equal to negative 17. So the two values for x and y are y is equal to 2 and x is equal to 17.